And welcome back to the Math Puzzle Crash Course. I want to take this problem a little slow, probably too slow for some, and if that's true, you don't have to watch the whole thing, and I'll try to point out the parts of it. But this problem is 6 divided by 2 times the quantity 1 plus 2. And this problem shows up quite often on the internet. It's very viral. People that post it. Hey, I'm going to admit it. I'm posting it, hopefully to get a lot of likes and a lot of views. But the reason this type of problem is very popular is because of some controversy. And I'll just say it right off the bat. It has to do with implicit multiplication. But we're going to get into that more as we go through the problem. And again, if you want to try to work this problem out, if you're not really sure, you can work this one out independently, and we'll come back and work it through together. And I'm going to explain the different approaches to this problem and hopefully help you understand why this problem shows up all over the internet, why it's so viral, and why people argue about it. All right, so first of all, I want to say the order of operations has been around for a lot of years. It has its roots all the way back to the 16th century in some of the very early books on algebra, going way, way back. So this is really nothing new. What is a little bit newer are different acronyms that people use to explain order of operations. There is a difference. The order of operations has been around a long time, is very old, but there are acronyms such as PEMDAS and BODMAS and BIDMAS and BEDMAS. They all mean the same thing. They're 6-letter acronyms, but they basically explain all the same 4 steps of order of operations. Some people refer to grouping symbols as parentheses or brackets, so that's where you get the P and the B. The E just represents exponents. The O of BODMAS is orders. The I of BIDMAS is indices. Basically, they're all talking about the same thing. The E is only mentioning exponents, but really, um, orders is a little bit better general term. They all represent, things like square roots, again, exponents, anything that's really considered a shorthand version of repeated multiplication. In other words, I could say 5 times 5 times 5, or I could say 5 to the third power, which is orders or exponents and or indices. It's a little easier to write 5 to the third power than to write 5 times 5 times 5. Again, going a little bit off topic, but again, these acronyms are often used as memorization tools. They do get some people in trouble because they forget what these represent. But we'll get into more of that as we go. Basically, I want to go through and explain the order of operations, and we're going to use PEMDAS as the example here. And what the P represents as step 1, parentheses, means that you resolve anything inside of the parentheses first. And again, if you're more familiar with BODMAS, if you're from the UK or whatever, you might refer to these as brackets, which is fine. Um, you solve everything inside of them first. Then number 2, you have exponents in PEMDAS, and exponents we don't even really have any here, so we're not too concerned about that. We do have parentheses, so I think everybody pretty much should agree that you would solve the 1 plus 2 first. Number 3, this is where people start to get confused on PEMDAS and BODMAS and so on. Step 3 is multiplication and division, and you solve those left to right in the order that you encounter them. PEMDAS does not mean you do multiplication before division any more than BODMAS means you do division before multiplication. Multiplication and division have equal precedence, and they're solved left to right. Division is nothing more than multiplying by a reciprocal. It's really the same operation, so they have the same priority. And then again, number 4 is addition and subtraction. And I see people even mess this one up, which is really, really shocking. But I've seen it happen a lot. Addition and subtraction have equal precedence. Um, and I don't even say they're solved left to right. It doesn't even matter the order that you do addition and subtraction. You're going to get the same result. It's just, subtraction is just adding a negative number. All right, so we've kind of reviewed that a little bit. So I think everyone generally agrees that, the first thing you look for are parentheses. And if you don't have parentheses, you just go down the line, which is another thing that people mess up a lot. But here it's pretty simple. I think everybody agrees that it's 1 plus 2 first. So 1 plus 2 is 3. That's great. Everybody gets that. Now, this is where people start to get confused a little bit. Step number 2, if you're going left to right, we actually encounter division before multiplication. So by the strict interpretations of PEMDAS, BODMAS, BEDMAS, BIDMAS, you do the division next. Division is next. 6 divided by 2 is 3. And I'm already hearing people screaming at their computer in the background telling me I'm an idiot because PEMDAS says multiplication comes first because the M is before the D. And again, that's one of those big misinterpretations of PEMDAS. I hear it all the time from people. No, you're supposed to do multiplication first. And that is not true. But we're going to get into another situation down the road. I told you before, right at the beginning, I said I was going to cover implicit multiplication. We will get to that in a little bit. But when you're looking at the strict interpretations of PEMDAS, you do the division first, going left to right. You end up with an answer of 9. 3 times 3 is 9. The next step would be multiplication after the division. All right, now there is a case for 1. Some people will say that the answer is 1. And the general reason for that is because you will see the implicit multiplication. There is a thing, it's also referred to as multiplication by juxtaposition. That's the convention, and it is a historical convention, goes pretty far back. Um, there is a second lesser known option. It has to do with how the obelus is the actual division symbol. It's the horizontal line with the dot above and the dot below. And we'll get into that strict interpretation here of the obelus. Now, what people do mess up, there are a lot of people that give an answer of 1, but they give an incorrect reasoning for it. And I've got it highlighted here in red. It's because I keep hearing this from people. Oh, the answer is 1 because you do the multiplication first. And what I'm going to tell you again is, and I keep stressing this over and over, PEMDAS is not a 6-step checklist. Multiplication does not take priority over division. Just because PEMDAS has the M before the D does not mean it goes first. That's not true. What is true is that there is this convention of, um, and again, when I'm talking about implicit multiplication, I'm saying when you have a number outside of parentheses, like we have on the right here, this is considered implicit multiplication. It's implied that we're multiplying 5 by 3. On the left side here, this is explicit multiplication. It's explicit because we're explicitly putting a multiplication symbol here. These both mean the same thing. It's 5 times 3 here, and it's 5 times 3 here. However, there is this convention. It's lesser used. It is used somewhat. It's not universally accepted, but it will show up in a lot of scientific and mathematics texts that are out there. That when you see multiplication like this, they give it a higher priority, even above explicit multiplication or division. All right, so hopefully that makes sense. Now, again, I'm going to say it again. According to the strict rules of PEMDAS, BODMAS, BEDMAS, and BIDMAS, and actually, I shouldn't say rules, I should say conventions. There is a difference between a rule and a convention. These are conventions. Does not mean they're arbitrary, but they're conventions. So I really should have written that as not as rules. But according to these strict interpretations of these acronyms, multiplication and division are just solved in the order from left to right. They're solved in order. No distinction is made between implicit and explicit multiplication. So let's get that out there right now. Um, when you're using those strict rules of PEMDAS and BODMAS, again, I should say strict interpretations of the conventions of PEMDAS and BODMAS, You solve inside the parentheses first. 1 plus 2 is 3. Everybody agrees on that one. But then it's division first, going from left to right. 6 divided by 2 is 3. And then you have the multiplication as you go left to right. So it's 3 times 3 is 9. Now again, if you're somebody who does follow. And I think sometimes this varies regionally. It also varies historically. I think Richard Feynman, who was a theoretical physicist, and a lot of his works, he utilized multiplication by juxtaposition. I'm not arguing with a theoretical physicist. It is a common thing that has been used through history, and again, it's not generally accepted universally at all, but it is out there. So just making people aware of it so that if you're claiming the answer is one, you need to at least have a good reasoning for it. But if you use this, you're saying you do solve inside the parentheses first. 1 plus 2 is 3. But then here, implicit multiplication would be solved before the explicit multiplication or division. Of course, we don't have any explicit multiplication, but we do have division. You actually, in this case, you do the 1 plus 2 is 3, and then you take 2 times 3 because multiplication by juxtaposition gives a higher priority, even though this multiplication is sitting right of the division that you see here. It would be done, the implicit multiplication would come first. So lastly, you would do the division. 6 divided by 6 equals 1. So you can justify it through this. You cannot justify it through PEMDAS, and that's what I see a lot of people doing. I see more people try to justify it through PEMDAS or BODMAS before even understanding what implicit multiplication is or what that convention even was all about. Um, and I'll say too, the obelisk is sometimes interpreted differently. Many people that have worked in a lot of science have seen, poorly written expressions like, you've got this here, you've got 1 divided by 2x, where you have the forward slash used. And a lot of times that's generally been interpreted, especially in scientific texts, to mean that you're actually saying 1 divided by 2x in the denominator, the 2x in the denominator. But, as you're looking at it with the forward slash, you could look at it differently. If you're writing it out using a forward slash, it can create confusion since it could also be interpreted as 1 half x. Does this x belong in the denominator with the 2, or is this supposed to be, in outside of that? Is it supposed to be 1 half times x? That's open to interpretation, honestly, there. And there is a book, was it Johann Rahn? I think he was a Swiss mathematician, if I remember right, but the obelisk was first used in that book way back in 1659. And the old interpretation of it back then, and it's even shown up in more recent text, I think even in the 1800s. I don't know much beyond that, but it was interpreted as having everything to the left being in the numerator and everything in the right in a denominator. In modern times, though, the obelisk generally means that the number to the immediate left is in the numerator, and the number immediately to the right of the obelisk would be in the denominator. So, in other words, like if you have a problem like 5 plus 10 divided by 2 plus 12, well, you look at the obelisk and you're really just looking at the 10 and the 2. 10 divided by 2 is 5, so this would simplify to 5 plus 12. That's equal to 22. The old interpretation would basically have 5 plus 2 in the numerator, the 2 plus 12 in the denominator, because again, the way the old interpretation of the obelisk was everything to the left in the numerator, everything to the right in the denominator. Not as common today, but I'm not going to say there's probably still some regions of the world that may look at it that way. Now, there is this famous picture. This one I got from Quora, but it's showing two different Casio calculators getting different answers for the same problem. It's the 6 divided by 2 times, the quantity 2, 1 plus 2. The one calculator on the left gave an answer of 1. The one on the right gave an answer of 9. It's even the same manufacturer. And like, well, what's going on here? Well, it really comes down to, what we're going to talk about here, and it's this priority of implicit multiplication, whether it's accepted or not. And we'll get into that. Actually got some manuals for a couple of these calculators that explain it. Um, Now, I will say too, a lot of people like to go on and on about the distributive property, and I've seen people try to argue for implicit multiplication. I've seen people argue against multiplication, and they're using the same mathematical properties to do it. It's just a matter of what you think has a higher priority. The distributive, and I'll explain, the distributive property is something that pairs three operations, okay? It's pairing multiplication, addition, and subtraction into pairs. And those pairs would be multiplication and addition or multiplication and subtraction. That's really all the distributive property is doing. Um, for example, like if you're with multiplication and addition, A times the quantity B plus C can be distributed out to also be equal to AB plus AC. In other words, A times B plus A times C. When you're pairing multiplication and subtraction, you could have A times the quantity B minus C, and using the distributive property, we know that's equivalent to A times B minus A times C. So where we get into issues here, where people will use this property and they'll do things like say, well, 6 divided by 2 is nothing more than 6 over 2, right? I mean, I could write it out this way, 6 divided by 2 times the quantity 1 plus 2, right? And in this case, the A, using the distributive property, A is 6 over 2, B would be equivalent to the 1 plus 2, and then using, the distributive property, keeping the fractions, you could write it out this way. And in solving it this way, you get 9. Now, of course, that all is dependent on saying that using the distributive property, your coefficient is the 6 divided by 2. But the people who believe in implicit multiplication, they'll simply tell you that the coefficient is 2, not the 6 divided by 2. So again, it's a circular argument. It keeps coming back to whether you believe implicit multiplication has precedence or not. You can argue this distributive property either way. The people that support one as the answer will just simply say no, using the distributive property. It's, the A is 2, B is the 1 plus 2, and you run through the distributive property and you get the answer of 1. But really, they're doing nothing more than giving precedence to the implicit multiplication. They're saying the coefficient is 2, not 6 divided by 2. So it's this, same argument. We're back to implied multiplication. Do you believe it has priority? Do you believe it's not? There's controversy. So let's look up the Casio FX 991W calculator manual. All right. All right. We've already looked at this, um, and we already looked at that. So that's our. Oh my goodness. Let's get right back to the calculator. We're back to the calculator again. So trying to go through or going in the wrong direction, obviously, right? Let's go back through the calculator manual, hit the wrong button. So here's right out of the calculator manual, and it does say down here in steps 7 and 8, it talks about the order of operations and like all the precedence of everything. When you get down to 7, it says abbreviated multiplication format in front of type B functions. So type B functions, you'd have to go up here and see what they're talking about. But they're giving priority to that. Number 8, permutations, combinations like NPR, NCR. And then finally down here, guess what? Then you have explicit multiplication, explicit division, right? Well, I guess there's no such thing as implicit division, but your multiplication division is here, but notice that they're giving a higher precedence to implicit multiplication, like 2 times the square root of 3, right? This is implied. There's no multiplication symbol here or a log 2, etc. So they're giving higher precedence to implied multiplication. So that's why that calculator gives you an answer of 1. Now here's the FX 570MS. This would be their, I think, the calculator, um, another calculator here where it says in the calculation priority sequence, the fifth step is implied multiplication of pi or the natural logarithm base, such as 2 pi, 3e, 5a, etc. Then you have your type B functions with square roots and so on. And then you have another implied multiplication. You get all the way down to step 10 where it says multiplication division. And this would be your explicit multiplication and division. And then finally your addition and subtraction. So you can see this calculator also is giving priority to implicit multiplication. And it's because that has been it has been a convention. It's been out there. Again, I'm going to say it's not universally accepted, but it is accepted in a lot of corners. It's been used a lot in science. And so this is why you're going to see different answers here on the calculators. And again, I'll just go back to this again. Too many have still argue based on a misunderstanding of PEMDAS. In PEMDAS, multiplication is not solved before division. It's not a six-step checklist, guys. Again, this is a little bit better description of what PEMDAS is, showing you that the multiplication and division are on one level and the addition and subtraction are on a level. And again, this graphic here kind of shows the different acronyms, PEMDAS, BODMAS, uh, GEMMA or GEMMA. I don't even know how they pronounce that one. But again, when it comes to the parentheses, the only thing these acronyms are concerned about is what's inside. Again, in small print, this priority does not apply to numbers outside of the grouping symbols. So hopefully that's been helpful. But again, I just wanted to cover this a little bit and explain why there is this controversy, and it's really coming down to whether you accept implicit multiplication. I know in North America, most of the education that's being done does not really cover implicit multiplication. It seems to be less and less stressed, but you will still come across it if you're reading through a lot of text. It's still used quite a bit in scientific calculations. So I just want to make you aware of it. It'd be a lot easier had this problem been written explicitly and just had the multiplication symbol in there. Then that really eliminates the controversy altogether. So hopefully this explanation's been helpful. If so, please consider liking, sharing, subscribing. And I do look forward to seeing everybody in the next video.